Okay, today we're going to be exploring this diagram, and we're going to be using it to do a series of things, including going to explore the diagram, build on the table of values, find the rule that goes with it, test it, and use the rule to predict the number of sticks in step 20. This problem would be appropriate for 4th or 5th grade because in 4th grade they start working with associating patterns and rules together. So we're going to start by exploring our diagram, and we're going to build a visual representation. So I'm going to start with step 1, and you can see that we have 4 sticks in step 1. So we have 1, 2, 3, and 4. And in step 2 we have 7 sticks. So we have 1, 2, 3, 4, 5, 6, and 7. And the last step we're going to build is step 3. We have 10 sticks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so I'm starting to notice a pattern as I'm building this that might help us with our rule. So I'm noticing for each step I did one white Q-tip to represent one step. So we have one white Q-tip plus 1, 2, 3 pink ones. So I'm going to go ahead and write that down. We have one white plus 3 pink. So for step number 2 we have again one white plus, see how many sets of 3 we have. 1, 2, 3, 1, 2, 3. So we have 2 sets of 3, so we're going to write 1 plus 3 plus 3. And that's for step number 2. So for step number 3, again we have one white Q-tip. We're going to write 1 plus, we have 1, 2, 3, 1, 2, 3, 1, 2, 3. So 3 sets of 3. 1 plus 3 plus 3 plus 3. So as I've written these down, I've noticed a pattern from our diagram. Each one begins with 1 plus a set number of 3's. So we're going to start writing our rule. We know that it's going to start with 1 plus, and I'm noticing a pattern between the number of steps we are and the number of 3's we have. So you can see in step 1 we have 1 3. In step 2 we have 2 3's, and in step 3, 3 3's. So since the number of 3's corresponds with the number of steps, I'm going to write our rule as 1 plus 3 times the number of steps, or you can call it x. So now that we've found a potential rule, we're going to test it. So let's bring our diagram back. We're going to see if we plug in 1, are we going to get 4 as our number of sticks. 1 plus 3 times 1, our number of steps. 1 plus 3 is 4. So we know that one's correct. The rule works for step 1, so let's try it with step 2. 1 plus 3 times 2, we're on step 2. 1 plus 6 equals 7. And the rule works again. I'm going to try it with step 3. 1 plus 3 times the number of steps, 3. 1 plus 9 equals 10. So we can see that our rule is working, so we're going to use it to keep building on our table. So let's figure out 4, 5, 6, and 7. So if we plug in 4 as our number of steps, 1 plus 3 times 4, 1 plus 12 equals 13. So we're going to plug that in as our number of sticks. Let's try it with step 5. 1 plus 3 times our number of steps. 1 plus 15 equals 16. So 16 is going to be our number of sticks for step 5. Let's do step 6 and 7 also. 1 plus 3 times 6. 1 plus 18 equals 19. So we're going to write 19 for step 6. And for step 7, 1 plus 3 times 7. So we have 1 plus 21 equals 22. So now you can see we've used our rule to fill the rest of our diagram in. And now we want to predict what the number of sticks is going to be for step 20. So we're going to plug that into our rule. So 1 plus 3, and we're looking for a number of sticks in step 20. 1 plus 3 times 20. So that's 1 plus 3 times 20 is 60. 1 plus 60 equals 61. So we're going to predict that we would have 61 sticks in step 20. We're working with this problem in this video, and this problem would be appropriate for grade 3 or grade 4 because in grade 3 they start using strip diagrams to solve problems. So we have William and Sally put 160 marbles into a jar. William put in 83 of the marbles. How many marbles did Sally put in? So first we're going to figure out what kind of addition problem type this is, and I decided that this would be a part-part whole because we have William and Sally as each part, and together they have a whole set of marbles. So we're going to fill in our parts on our chart right here. So if they had 160 marbles in a jar together, that's going to be our whole. So 160 is going to go there. William put in 83 of the marbles, so we know that that is William's part. So part 1 right here is going to be William, and we know that he put in 83. We weren't given the number of marbles Sally put in. That's what we're trying to figure out. So I'm going to put a question mark in part 2, which is going to be Sally's marbles. So this is the type of problem we're doing, part-part whole. We have one part, we're finding the other one, and we have our whole of 160. So we're going to look at this using strip diagrams. This is going to represent our total number of marbles, which is 160. And then this pink strip is going to be part 1, which was William's marbles, and that is going to equal 83, since that's how many marbles the problem said William had. So what we're looking for is the rest of this right here, and this is our part 2, Sally's marbles, and you can see that right here, these are even, so that's what we're looking for. How many right here is going to make 160 marbles together? So as we figured out from here, our problem is going to be 83 plus the other part equals the whole, which is 160. So I'm going to write that at the bottom right here. 83 plus our other part equals 160. Alright, so now that we've looked at it visually right here, we're going to figure out how many marbles Sally had. So we're going to do 160 minus 83 to get our mystery number of marbles. So I got 77 as my number of marbles that Sally would have, so we're going to test that to make sure it's correct. And we're going to plug it into here. So 83 plus 77 equals 160. So let's test that and see if that's correct. So I said 83 plus 77. 3 plus 7 is 10. 9 plus 7 is 16. 160 marbles. The next problem that we're going to be working with is this one, and this would also be appropriate for probably grade 3 or grade 4 because of their use of strip diagrams. And this one says, Summer has some shoes. She gets 4 more. Now she has 12. How many shoes did she start with? So what I gather from this is that we have a total number of shoes that she has, and we have, in the beginning we don't know the beginning number, and then she gets 4 more. So I chose a join problem type for this because we have a start, which that's the number we're looking for because it says she has some shoes, but we don't know how many. So I'm going to put a question mark in our start. And then we know the result. It said she ends up with 12 shoes. So our result is 12. And then the change, she changed the beginning number she had by getting 4 more, and she's adding those. That's why our arrow is going into the start. So I'm going to put 4 in our change. So looking at this, we can go ahead and build it into an equation. So our start plus our change is going to equal our result. So our start, we don't know. We're going to keep it as a question mark. Plus our change is 4. And that's going to equal our result, which is 12. So now we've used our join problem type diagram to create an equation, and we're going to look at it using strip diagrams now. So we have start plus 4 equals our result, 12. And so I have an orange strip right here, and that's going to be our result. So this strip is going to equal 12. And then I have another strip right here, and this is going to be her change in the problem. So right here, this is her change, and we know that her change is 4. So we're going to label that as 4. And then this right here is going to be our question mark. So this is the number of shoes she started with. You can see that when you add up the sides, these two strips should add up to the same length as our result. So now we're going to figure this out. We're going to figure out what part, when joined with 4, is going to equal 12. So I'm going to do 12 minus 4 and that equals 8.